This poster is about how the photochemistry of gas molecules in Earth's atmosphere determines the structure of the atmosphere and the average temperature at Earth's surface. There are only three ways air is warmed by absorbing radiation. First, in the troposphere is heated from below by Earth's sun-warmed surface, much like air above a hot frying pan. The tropopause is the boundary between the troposphere, heated from below, and the stratosphere, heated from above. Second, the stratosphere and mesosphere are heated from above when solar ultraviolet radiation dissociates primarily oxygen and ozone, breaking a molecular bond, causing the molecular pieces to fly apart at high velocity, converting kinetic energy of bond oscillation completely and efficiently into kinetic energy of linear motion, which is proportional to gas temperature. Third, the ionosphere is heated from above when solar high-energy radiation ionizes primarily nitrogen, oxygen, and nitric oxide, causing the electron and the ion to fly apart at high velocity, converting kinetic energy of oscillation of the electron bond completely and efficiently into kinetic energy of linear motion, which is proportional to gas temperature. Atmospheric structure is determined by solar radiation absorbed in the atmosphere. The highest frequency, highest energy solar radiation ionizes gases in the ionosphere, warming the ionosphere. Dissociation primarily of oxygen at frequencies around 1237 terahertz and ozone at frequencies around 1071 terahertz warms the mesosphere and stratosphere. Essentially, all ultraviolet C and higher frequencies are absorbed in the stratosphere and above. Most ultraviolet B is normally absorbed above the tropopause, which is essentially the base of the ozone layer. The troposphere is warmed by warm air convecting above Earth's sun-warmed surface. Photodissociation of oxygen and ozone occur in cycles that continue over and over as long as ultraviolet C and ultraviolet B are available. Two oxygen atoms, when close enough together, recombine without absorbing heat to form an oxygen molecule that is then dissociated at a cycle that continues to heat the stratosphere as long as ultraviolet C radiation is available. Similarly, an oxygen atom and an oxygen molecule, when close enough together, recombine without absorbing heat to form a molecule of ozone that is then dissociated in a cycle that continues to heat the ozone layer as long as ultraviolet B radiation is available. Normally, nearly all ultraviolet B is absorbed in the ozone layer. When the ozone layer is depleted, more ultraviolet B than usual is observed to reach Earth, cooling the ozone layer and warming Earth. Ultraviolet B is the most energetic, hottest solar radiation that can reach Earth, where it causes sunburn, skin cancer, cataracts, and mutations of DNA. Ultraviolet B dissociates ground-level ozone pollution and penetrates oceans tens of meters, raising ocean heat content. Cfc gases manufactured in the 1960s for use as refrigerants, spray can propellants, foam blowing agents, and solvents released atoms of chlorine in the lower stratosphere. One atom of chlorine can destroy 100,000 molecules of ozone under the right conditions. Ozone depletion caused by manufacturing CFC gases resulted in 0.6 of a degree Celsius warming from 1970 to 1998. Ultraviolet B dissociates ground-level ozone depletion, warming air, especially in populated areas where ozone pollution is greatest. Ultraviolet B penetrates oceans tens of meters, raising ocean heat content. The United Nations Montreal Protocol on substances that deplete the ozone layer mandated severe cutback in manufacturing of CFCs beginning in 1989. Sure enough, by 1993, the concentration of CFCs in the atmosphere stopped increasing. By 1995, the depletion of the ozone layer stopped increasing. By 1998, temperature stopped increasing. Humans had caused the warming by manufacturing CFCs. Then humans stopped the warming by passing the Montreal Protocol. But the ozone layer is expected to remain depleted for most of the rest of this century, continuing to increase ocean heat content. Warming was greatest in the northern hemisphere, where 90% of people live. Dissociation of ground-level ozone, pollution, explains one major reason why warming was greater in urban areas. Warming was greatest on the Antarctic Peninsula, when and where ozone depletion was greatest. Warming due to ozone depletion explains Arctic amplification. Ozone depletion is also caused by basaltic lava flows. Basaltic lava flows release megatons of chlorine and bromine that is observed to deplete ozone in the ozone layer. Beginning on August 29, 2014, Bardarbunga volcano in Iceland erupted for 6 months. The largest basaltic lava eruption since 1784, causing 2016 to be the warmest year on record. Beginning on May 3, 2018, Kilauea volcano in Hawaii erupted for 3 months, the largest lava flow in Hawaii since 1960, causing warming in 2019 and 2020, when the average global temperature is likely to be extremely close to the maximum temperature in 2016. Throughout Earth history, basaltic lava flows covering hundreds to millions of square kilometers of land have been contemporaneous with major warming. The larger the basaltic lava flow, the greater the warming. Annual global temperatures are roughly proportional to total column ozone. While there are many factors involved and many details to be studied, average global temperatures since 1927 have risen when ozone becomes depleted, roughly at a rate of about a half a degree Celsius increase in temperature per 10 Dobson unit decrease in northern mid-latitude total column ozone. Greenhouse gases absorbing infrared radiation cannot warm air. Infrared radiation does not have enough energy to dissolve anything. There is no physical way known that greenhouse gases absorbing infrared radiation can warm air. Carbon dioxide absorbs less than 16% of the frequencies radiated by Earth. Temperature of Earth is the result of all frequencies and intensities shown in green. All curves of warming or cooling are asymptotic to their final temperature, showing that heat flowing per second is proportional to the difference in temperature. Therefore, if Earth's atmosphere warms, it would lose more heat to space, cooling Earth. To understand the fundamental problem with greenhouse warming theory, we need to look at the difference between physical properties that are either extensive or intensive. Extensive physical properties describe external measurable properties or motion, typically of a macroscopic body of matter. Examples are length, area, volume, size, mass, weight, quantity, or amount. Extensive physical properties measure how much of an object exists and changes when the size, extent, amount, or mass of a sample changes. Extensive physical properties are a macroscopic quantity or amount of something. Extensive physical properties are additive, meaning they can be added together or integrated as a function of. Intensive physical properties, on the other hand, result from the physical properties or relative motion of atoms and molecules distributed evenly throughout a body of matter. Examples are temperature, heat, density, color, or hardness. Intensive physical properties are a bulk property that does not change when the size, extent, amount, or mass of a sample changes. Intensive physical properties are a submicroscopic distribution of properties that coexist. Intensive physical properties cannot be added together in any physically meaningful way. Greenhouse warming theory assumes heat is extensive and additive, but heat clearly is intensive and not additive. This is why greenhouse warming theory grossly overestimates the effects of greenhouse gases, and why all calculations done by state-of-the-art computer models of climate are mistaken. Future temperatures should decrease slowly as the ozone layer recovers to pre-1970 values. Temperatures and heat are intensive physical properties that are not additive, as assumed by greenhouse warming theory. Heat simply does not flow in the ways assumed by greenhouse warming theory and by the Intergovernmental Panel on Climate Change, the IPCC. All observed global warming throughout Earth history appears to be explained in considerable detail by depletion of the ozone layer. Greenhouse warming theory is rapidly becoming the most expensive mistake ever made in the history of science, economically, environmentally, and politically. How long will it take scientists to look at the data and conclude that their extensive consensus is mistaken? The details are contained in this published paper, The Photochemistry of Gas Molecules in Earth's Atmosphere and the Average Temperature at Earth's Surface. More information is available at these web links. Thank you very much.